All right, welcome to another fabulous lesson. Today's topic is going to be on solving absolute value equations. So go ahead and put this topic at the top of your notes page so that you can easily identify these notes when you are trying to use them in class. And today's learning goal is I will be able to solve absolute value equations. No need to copy down the image that's at the bottom of the screen. It's just giving you a little bit of a preview of what today's lesson is kind of going to look like. So again, today's lesson is on absolute value equations, and I will be your flight attendant for today's lesson. I do want you to copy these steps into your notebook. These are the steps on solving absolute value equations. And there are 4 steps that you will need to follow in order to successfully complete these problems that we have coming up. So go ahead and pause the video and get these copied down. Pause the video and go ahead and get these copied down into your notebook. All right, so now that you've paused the video and you've gotten these copied into your notebook, I want to bring to your attention something that I use for step 1 with my students. Is called SADMEP, which is technically, if you take PEMDAS and you write it backwards, PEMDAS is used for order of operations to solve expressions, but if you write it backwards, it tells you the order to solve your equations in. So all of the letters still represent the same thing. S for subtraction, A for addition, D for division, M for multiplication, E for exponents, and P for parentheses. So our technical first goal in solving absolute value equations is to always isolate the absolute value. So those 2 long bars, we read those as the absolute value. So to isolate the absolute value part of our equation first, double check to make sure it's not equal to a negative, because if it is, it's no solution. If it's equal to 0 after we isolate the absolute value part of our equation, it will only have one solution. And pretty much once those absolute value bars are on a side by itself, we have to use our trusty dusty plus or minus key, plus or minus symbol. Okay, we use plus or minus symbol with absolute value as well. Same way we use plus or minus when we take the square root. We also have to use plus or minus when we're dealing with absolute value. And then we split it into 2 equations and we solve. We have to split it into a positive equation, 1 negative equation, and then we continue to use SADMEP and to isolate our variable, and we make sure we solve each equation separately in order to get our final answer. So let's get it. And again, just to reiterate that this symbol here is read as the absolute value, And the reason why we have to use plus or minus is because anything that comes out of the absolute value symbols cannot be negative. Absolute value is technically like distance, so distance is not negative. No one can run negative 3 miles. You can't drive negative 200 miles. So distance can't be negative. That's why absolute value, you have to use plus or minus. Go ahead and get this one copied down. This one is going to be a we do this one together. So go ahead and get this copied down. This is read as the absolute value of M minus 6.4 equals 9. And I'm going to go ahead and write SADMEP. I'm going to go ahead and write SADMEP down because we have to use PEMDAS backwards to isolate the absolute value part of our equation. But what do you notice? If I draw my wall, and I like to use walls to clearly show the difference between the left side and the right side, what do you guys notice? Exactly. The absolute value symbol is already on one side by itself. The absolute value part of the equation is already on one side by itself. So then we will now check to see, is it equal to a negative? And it's actually equal to a positive 9. So we know we're going to have solutions. Step 2 says once the absolute value is on one side by itself, add the plus or minus in front of it. So I am going to rewrite my equation But now I have to make sure that I include the plus or minus symbol in front. So this is step 2. And then step 3 says to split and write 2 separate equations. We're going to split it. We're going to bust this equation wide open. We're going to split. So when I split, I end up with 2 separate equations. Now, what it also says is that only changing the sign of the number behind the plus or minus. So that means nothing else gets changed except for the number behind the plus or minus. So when I write my first equation, I'll write m, the absolute value of m minus 6.4 equals a positive 9. Notice what was on the left side did not change. When I go to write my negative equation, I still keep my absolute value of m minus 6.4 equals, but this time it's got to equal negative 9. So notice that the only thing that changed was the number that is behind that plus or minus sign. Nothing else changes. So don't go up here making up your own math problems. Only change the number behind the plus or minus. Okay? All right, so from here, now we just draw our walls and we solve these individually. You can kind of basically ignore the absolute value symbols at this point and just solve. We're going to go ahead and use the SADMEP. So do I see subtraction? Yes. Yes, I absolutely see subtraction. And what's being subtracted? Correct, that 6.4 is being subtracted. The opposite of subtraction is addition. Yes, and what you do to one side, you absolutely must do to the other. And when I use my handy dandy calculator, then I see that I end up with 15.4. Now notice I solved this equation completely separate. I did not come do something over here and turn around and do it on the other one. I'm treating them as 2 separate entities. Now we're going to go to the other side, go through my PEMDAS backwards. Oh, do I see subtraction? I absolutely see subtraction. The opposite of subtraction is addition. So I will add 6.4 to both sides. If you didn't draw your wall and you need it, draw your wall so you can clearly make sure that you're going from one side to the other. These will cancel out. And then again, I use my handy dandy calculator. And when I put it in my calculator, I end up with a negative 2.6. So these are my answers. These are my answers. So pause the video as needed. Rewind it if you missed any of that. Because guess what's coming up next, guys? You got it. You guys have a you do. All right, so go ahead and pause the video. Pause the video. Give yourself about 3 to 3.5 minutes on the clock. No more than 4 minutes. Go ahead and give this a try, but I will give you a trusty dusty hint. Do not forget to use your PEMDAS backwards. That's SADMEP to help you to know what operations you're going to get rid of first. So pause the video and give it a whirl. Alrighty, so hopefully you paused the video and you were able to get at least the first couple of steps taken care of. If you look at the original problem, the absolute value is not by itself, so I do have to do some movement. Did I see subtraction? I did not see subtraction outside of the absolute value. So I want you to think about those absolute value bars as parentheses. So we've got to take care of everything that is outside of those absolute value bars or quote unquote parentheses. We got to get rid of everything outside of it first before I can start working on it. Because I know somebody said, but I did see subtraction, x minus 3. That's subtraction, lady. I know you saw it, but it's technically in prison right now. And we got to get rid of everything else around it. So I did see addition. The opposite of addition is subtraction. Subtract on both sides. And now you should have noticed that I don't have anything else left with my absolute value bars. So I have to put that plus or minus in front of the answer that I got when I subtracted 6. So it's now plus or minus 6. And now we got to split them up into two separate equations. But notice the only thing that changed was I have equals positive 6 on one equation and I have equals negative 6 on the other equation. You may also notice that I got rid of the absolute value bars because you don't really need them once you've isolated it and you've split it into your two separate equations. Going back to do SADMEP a second time, this time I can actually handle that subtraction that most of you guys said from in the first step. Opposite of subtraction is addition. Add 3 to both sides. In both equations, notice that my steps are identical. I added 3 to both sides in both equations, but because my number behind the equal sign is different, I end up with different answers. So that's a hint as to whether or not you're on the right track. Did you do the same step after you split the equations? The only thing that should be different is the final outcome. So pause the video and rewind as needed, and we're getting ready to move forward again. Okay, so this one, we're going to do this one together. This is a we do. I'm going to do this one with you guys. Yay! So go ahead and get this copied in your notebook. And we're also going to make sure that we put our SADMEP off to the side so that we can properly handle our problem. So it says use SADMEP to isolate the absolute value part of our equation. So most of you guys may think that this is actually by itself, but do you see something? I mean, it's kind of tiny, but do you see it? I see it. Yeah, there's this minus sign that's right there, that negative sign. It's just like right there. It's in front. But the question would be, what operation is this technically? Like, is this subtraction or is it something else? Is this a negative sign or is this a subtraction sign? Well, what always comes behind a negative that's completely by itself? You might have remembered seeing this when we were dealing with polynomials and you had a minus sign in between a set of parentheses. And what did we always have to remember to write? Well, yes, we had to remember to write that invisible 1. So we're going to put an invisible 1 here, and that's going to help us to see what operation this really is. This is negative 1 times everything that is inside of these parentheses. So this is technically not subtraction. It's not addition. If it were division, I would see a fraction. I do not have any fractions, so therefore I do not have any division. And we already said this is negative 1 times whatever is inside of here. So we do have to deal with multiplication. So we ask ourselves, self, and self said yes, what is the opposite of multiplication? It is division. So I'm going to divide both sides by negative 1. Divide both sides by negative 1. And these babies here should actually cancel out. On the left side, I will be left with the absolute value of 8x minus 6 equals, and what is a positive divided by a negative? A positive divided by a negative is a negative, and 3 divided by 1 is 3. So I have the absolute value is equal to a negative 3. Now I want you to go back to your steps that you wrote down, and underneath step 1, it says if your equation equals a negative, it is a what? It is no solution, okay? Because absolute value cannot be negative. This is a negative 3, so this is no solution. We cannot go any further on this problem. Now, y'all know I was going to do the easy one with you because guess what's getting ready to come up? You got it, dude. Pause the video and rewind it if you need to before you move on to the next question. But the next question, you already know what you gotta do. So this problem is a you do. You do. This is a you do. So go ahead and pause the video. Pause the video. And give yourself about 4 minutes on a clock. and do your best to try to knock this problem out. Remember to do your PEMDAS backwards. So write SADMEP and utilize it. My hint to you is remember the absolute value bars are like parentheses. So you can't touch what's inside of the parentheses until we isolate those bars on one side by themselves. And keep in mind that if we see division, it would have to be a fraction. And those are the only hints that I'm going to give you. So pause the video and make it happen, Cap'n. All right. So this is what you should have gotten. Hopefully you were able to fully complete the problem, but if not, see where you started to make your first mistake. We did have subtraction, what was being subtracted. Again, I know you guys think you see a negative 5x. However, again, it's inside those absolute value bars, so that's not what we're talking about right now. Those bars are like parentheses, so we'll deal with that later. What was really being subtracted, it was the -9. Opposite of -9 is adding 9 to both sides. After we simplify everything, we notice that we have that 6 in front of our absolute value bars. And again, that would almost be like having 6 in front of a set of parentheses. It's like saying 6 times whatever's inside those absolute value bars. So the opposite of multiplication is division. Okay, so we had to divide by 6. The opposite of multiplying by 6 is to divide by 6. Then I simplify everything. Now I'm completely done with step 1 because I have the absolute value bars all by its lonesome. Have to remember to do step 2, which is to add in that plus or minus symbol in front of my number that's on the other side all by itself. And then I gotta split. And then I need to do some PEMDAS backwards in order to finish solving. So want to bring to your attention some things here. 1 minus 5x is technically not subtraction in this case. It is technically -5 times x. So I would not add 5x to both sides as some of you might have done on your paper. This is -5 times x, so I will not touch this initially because it's technically multiplying by a negative. But I did have addition, and that was a +1. So if I wrote that in reverse, it would have been -5x plus 1. So I'm technically adding 1. So the opposite of adding 1 would be to subtract 1 from both sides. That's what we did in both equations. And then divide by the number that's in front of your variable, because anytime you have a number and a variable touching, that is considered to be multiplication. So opposite of multiplication is division. Last thing that I want to bring to your attention is on our right hand side, when we actually wrote equals -11, we ended up with fractions. Now 12 divided by 5 will not give me a whole number. Sometimes on tests they may ask you to actually put that in your calculator and give them the decimal form. Other times you'll just leave it as a fraction. So even though 12 cannot go evenly into 5, I still have to simplify my signs. And what is a negative divided by a negative? It is a positive. So I had to make sure that I changed my final answer into a positive 12 divided by 5, or 12 over 5. Go ahead and pause the video, rewind anything that you may not have understood, and happy solving!